All right. These are the notes. I made a video and only 13 seconds of the video posted, so this is a second try at. These are Monday's notes for Chapter 5, Section 1. Chapter 5 is all about polynomials and exponents. Section 1 is about the whole principle behind exponents and how they work. Just as a reminder, when you're dealing with exponents, you have a base and you have an exponent. The base is a number or expression or phrase or variable that is used as a factor exponent number of times. So when we say 10 to the third power, what we really mean is that we're going to use 10 3 times as a factor. Namely, 10 times 10 times 10, or 1,000. Powers of 10 are easy. That just tells you how many zeros there are. There are properties that are involved with exponents. There are a number of properties, or rules, if you will. There's rules of operations. There's properties that indicate what can be done and how it can be done. The first one that we want to look at is called the product of powers property. The product of powers property. It's the product, that is, we're multiplying two things, and we have powers on each of those things. And the way the rule works is that when you have a to the third times a to the fourth, it's a to the 3 plus 4, which is a to the 7th. Another way you could see this is, again, what does this mean? This means a times a times a. What does this mean? A times a times a times a. How many a's do you have? We only have 6 classes, so the most you could have is never mind. 1, 2, 3, 4, 5, 6, 7. A to the 7th. But the shortcut, you don't have to write it all out in expanded form. You can do a shortcut and just add the exponents when the base is the same. And that rule is called the product of powers property. The formal way of looking at it is this. If we have a to the r power times a to the s power, what we get is a to the r plus s power. That's one rule, property. Here's the second one. Second one is the power of products property. The power of products property. So if we have a times b raised to the third power, what we have is a to the third power times b to the third power. It's kind of like the distributive property, where you're distributing this 3, this exponent, to each of the bases that are factors. 3 to the 4th power, 3 times 4, that product raised to this power. So it's the power of a product. And this, you can show that it works by going both directions. We can put this with each of these. So we have 3 squared times 4 squared. Or we could do this product, 3 times 4, which is 12, and then square that. Of course, 12 to the 2nd power is 144. 3 squared is 9, 4 squared is 16, and 9 times 16 is also 144. And that's where the utility or the usefulness of this comes in, when you can do it either of these two ways. Power of products property. Glad to see you're listening. A third one we can call the quotient of powers property. Remember, quotient is the result of division. Quotient is the result of a division problem. So here we have a quotient of powers. And the ruling here is that when you have a quotient, the same base in the numerator and the denominator, you subtract the exponents. 3 minus 2, which is a to the first power. This is a drawn out version of it, if you want. Let's play with colors here. Another way of looking at it is, what is a to the third? It's a times a times a. What is a squared? A times a. And these are factors, so we can actually cancel out the ones. So this is a 1, this is a 1. That leaves a by itself. Oh boy, where did I go? I'm so sorry. I went too far. Oh no. Oh no. Oh no. Oh no. There we go. Almost blew that. All right, so that's the quotient of powers. Quotient of powers property. Next we have the power of quotients property. That is, we have a quotient that we're raising to a power. So we call it the power of quotients property. Again, what happens is we can apply this exponent to each, the numerator and the denominator. So we have a to the 5th squared, b squared squared. So b to the 2nd squared. And then we go back to our earlier to a different rule that I haven't given you yet, which is what ends up giving us this right here. So this is called the power of a quotient property. I'm going to go back and forth. So this is called the power of powers property. The power of powers. That is raising an exponent to an exponent. That is raising this power to this power. A to the 5th raised to the 2nd power. So that's the power of a power property. What's the rule? A to the 5th squared is the same as a to the 5 times 2, or a to the 10th. And this is a generalized way of looking at it. What does a to the 5th mean? It means a times a times a times a times a. What does the 2 stand for? Then I'm going to do this twice. So I have a times a times a times a times a times a. Okay. So what can you do? You count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A to the 10th power. Why do all that work? I'm just as lazy as most. Okay, I'm not as lazy as some of you, but the rule here is you raise the power to a power by multiplying. 5 times 2 is 10. That's the shortcut. That's the long way around. Don't need to do that. And that's what we used here. A to the 5th squared is a to the 10th. B squared squared is b to the 4th. Okay? Power of powers property. Here's 2 more rules, and I don't have a distinct name for them, but unless you want to call this the reciprocal of powers. That's not a powers. Oh no, what's up in Mr. Bill? I'm really messing up now, aren't I? So this is the reciprocal of powers. Reciprocal of powers property. How does it work? Well, if you have a base raised to a negative exponent, you can simply take the reciprocal of this. A over 1's reciprocal is 1